Hello and welcome to another one of these ADD videos. Today we're going to be looking at how to draw Lewis structures for ammonia. First step, as always, is to add up all the valence electrons. If you remember, you get your valence electrons for the group number that we're in. Okay, so nitrogen, as you can see, is in group 5, hydrogen in group 1 over here, even though this periodic table has it in the middle over here. So we have 5 valence electrons for nitrogen because it's in group 5a, and then 3 for hydrogen. Now we draw the skeleton structure. Typically we want the least electronegative element in the middle, and we also want to watch out for symmetry. In this case, hydrogen can only form one bond, so it has to be on the outside. So that would be your skeleton structure. The next thing we're going to have to do is draw the bonding electrons. Each line is going to be 2 electrons, and we're going to take those numbers of bonding electrons and we're going to subtract from the valence electrons to determine the number of lone pairs. Okay, so each of these need one bond in between them. So 2, 4, 6, the total of 8 valence electrons minus the 6 bonding electrons. 8 valence minus 6 bonding gives me 2 lone pairs. The only place that really can house those lone pair electrons is nitrogen. All right. Next thing we're going to have to do is test our formal charge. Formal charges will help us know if we've got a valid Lewis structure. Let's say if we added all the formal charges and we got a -1 or a +1, we know that we did something wrong. If you remember, the formula for formal charge is the valence electron number, which was the group number, minus the number of bonds, plus each individual lone pair electron. Not the pairs, but the individual electrons. All right? So if you were to calculate it for nitrogen, nitrogen is in group 5 valence electrons. It's got 1, 2, 3 bonds, plus 1, 2 lone pair electrons, so that's a 0. If you were to do the same thing for hydrogen, you only have to do it for one of these hydrogens because they're all bonded to a nitrogen with a lone pair. There's no distinction between any one of these hydrogens. So its valence is 1 valence electron from the group 1a, -1 bond, 0. The net charge does match up, so we know that everything's okay, because if it doesn't equal the sum of the individual formal charges, then we did something wrong. All right? All right, so we're going to now draw the Lewis structure for water, H2O. As always, the first step is to add up the valence electrons. So we know that if we go to the periodic table, hydrogen's still in the first column. Oxygen is in group 6, so it has 6 valence electrons. There's 2 hydrogens, so 2 times 1, group 1a, plus 6 is 8. These are your total valence electrons. Now we draw the skeleton structure. So the skeleton structure is going to have oxygen in the middle because hydrogen will never be in the middle. It can only form one bond. Now we're going to draw the bonding electrons, and remember, each line is 2 electrons. And we're going to add them up, and we're going to subtract from the total number of valence electrons. And that's going to tell us how many lone pair electrons we have left. So 2, 4, 8 minus 4 is 4 lone pair electrons. 8 valence electrons minus 2, 4 bonding electrons is 4 lone pair electrons. So we can know that they're going to go around oxygen for 2 reasons. One, hydrogen can't hold any more electrons. Its valence shell is full, and oxygen's octet is not completed. It does not have a noble gas configuration. It's not happy. So we put the 2 sets of lone pair electrons, or 4 individual electrons, lone pair electrons, around the oxygen. 4. Now we got to check the formal charges. Again, the formal charge formula is valence electron number minus number of bonds plus lone pair electrons. So for oxygen, it's in the 6th group, so valence is 6 minus it formed 1, 2 bonds plus 1, 2, 3, 4 individual lone pair electrons. So that gives us a formal charge of 0. For hydrogen, 1 minus 1, that comes from the valence number and the 1 bond. A lot of people try to count both these bonds. We're just talking about one of these hydrogens. They're both the same, so the charge applies to both hydrogens, but when we calculate it, you just look at the 1. Why do we calculate formal charge? Well, we want to have the most stable structure for a Lewis structure, the most valid Lewis structure, and it's going to be the one that has the fewest formal charges with the most number of bonds. Furthermore, we want the net formal charges to add up to the charge of your problem. So this is neutral. This better add up to 0. So again, the net charge of H2O, in this case 0, should be what the sum of the individual formal charge for each atom in your compound. All right? So as always, the only way you're going to get better at this stuff is to practice a few. Don't let them intimidate you. They do get a lot more complicated than this. Check out the intermediate and advanced videos. But more importantly than checking out videos, going to tutoring, or anything else, is just to practice a few on your own. Can you do it without anybody else's help? Until you can sit down and practice a few of these, you won't know the answer to that question. So good luck. Thanks for watching. Have a great day.